Hi, welcome to my fourth video in the playlist of TL12th Mathematics chapter 1 applications of matrices and determinants. So far we have been discussing about what is determinant, why we need determinant, and in the previous video I talked about how to add two matrices, how to subtract two matrices, and how to multiply and how to find the inverse and adjoint of a matrix. In this video and for the upcoming videos I am going to solve the exercise problems which is in 1.1. So after solving the exercise problems, and I will solve some theorems which is in examples. So I will solve up to 4 to 5 theorems in examples after completing the exercise number 1.1. So it's very easy, since you already know how to find the inverse, adjoint, determinant. It's very easy to follow. First, the question which is find the adjoint of the following matrices. So before getting into this, you kindly note down the two important results which I am going to use for solving the problems. First one is CA, the whole inverse. That C is any scalar, there is any C is any constant. So CA whole inverse is, suppose if we want to take C out, we ought to take it as 1 by C. Since it has inverse, so CA whole inverse is equal to 1 by C of A inverse, and adjoint of lambda A is equal to lambda power n minus 1 into adjoint of A, where here n denotes the order of the matrix. Suppose if I have 2 cross 2 matrix, n is 2. Suppose if I have 3 cross 3 matrix, n is 3. So these are the three important results which I am going to use in solving the problem. First question is find the adjoint of the following matrices. So the first question is A. I taken that matrix as A, which is minus 3, 4, 6, 2. Now how to find adjoint of A? So kindly recommend you to watch the previous videos. So adjoint of A is, so these two numbers will get interchanged. So 2 goes here, minus 3 come here, and then you want to put these numbers as it is, and then you want to multiply by minus. So இப்போ என்ன பண்ணோம் அப்படின்னா, நீங்கள் இந்த ரெண்டு நம்பரையும் மாற்றி போட்டுக்கணும், இந்த ரெண்டு நம்பர் அதே நம்பரை போட்டுக்கிட்டு மல்டிப்ளை மைனஸால் மல்டிப்ளை பண்ணிக்கணும். ஸோ திஸ் வெரி ஈஸி. திஸ் is the adjoint of A. Now second question, A, I'm taking that matrix as A, which is 2, 3, 1, 3, 4, 1, 3, 7, 2. So we need to find the adjoint of A. So we know how to find the adjoint for a 3 cross 3 matrices. So adjoint of A is determinant of, first you want to start with the pivot element which is 4. So 4, 1, 3, 4. So 4, 1, 3, 4. And then you want to consider the next row which is 7, 2, 3, 7. And you take it as 3, 3, 1, 2, 3, and again you want to finish up with the same row which is 4, 1, 3, 4. And then important thing is that you have to put transpose at the top. So we have 4 2s are 8, in between it should be minus, so 7 into 1 is 7. So 3 minus 6, 21 minus 12. So these are the 21, 4 3s are 12, and again you take the next row which is 7 minus 6 and 2 minus 3. So in between you have to put minus and you have to be very careful, and 9 minus 14, and again 3 minus 4, and 1 into 3 is 3, minus 2 into 1 is 2, and 2 into 4 are 8, minus 3 into 3 is 9, and then transpose. Now 8 minus 7 is 1, 3 minus 6 is minus 3, 21 minus 12 is 9, and 7 minus 6 is 1, 2 minus 3 is minus 1, 9 minus 14 is minus 5, 3 minus 4, 3 minus 2 is 1, and a minus 1, and then transpose. So you have to change the column to row, which is 1, 1, minus 1. I am getting this column to row, which is minus 3, minus 1, 1. I am taking this column to row, 9, minus 5, minus 1. So this is the adjoint of the following matrix. Very easy. இப்போ என்ன பண்ணியிருக்கேன் அப்படின்னா முதல்ல நான் என்ன ஆரம்பிக்கணும், இந்த நம்பர்லேருந்து ஆரம்பிக்கணும். 4, அப்புறம் 4 1 3 4, அப்புறம் அடுத்த ரோ 7 2 3 7, அப்புறம் 3 1 2 3, அப்புறம் திரும்ப அங்கேயே முடிக்கணும் எங்கே ஆரம்பித்தோமோ. ஸோ 4 1 3 4. இப்போ என்கிட்ட 4 ரோ 4 காலம் இருக்குது. இதுக்கு டிட்டர்மினன்ட் போடணும். இது எப்படி போடணும் அப்படின்னா 4 2 மைனஸ் 7 into 1. ஸோ இதே மாதிரி எல்லாம் பண்ணிட்டே வந்தீங்க. அப்புறம் டிரான்ஸ்போஸ் பண்ணணும், ரொம்ப முக்கியமான விஷயம் அது. டிரான்ஸ்போஸ் என்ன பண்ணோம் அப்படின்னா ரோவை காலமாக எழுதணும். ஸோ நான் காலமை ரோவாக எழுதியிருக்கேன். ஸோ this is the adjoint of the following matrices. Very easy. I'm going to the next problem, the third problem, which is A is equal to 1 by 3 2 2 1 minus 2 1 2 1 minus 2 and 2. We need to find the adjoint of A. இப்போ நீங்கள் பார்த்தீங்க அப்படின்னா we already know one result, adjoint of lambda A, where lambda is any constant. Constant constant ஒரு number. So adjoint of lambda A is equal to lambda power n minus 1 into adjoint of A. So this is a result which I wrote at the starting, which is adjoint of lambda A is equal to lambda power n minus 1 into adjoint of A. So when you compare this, I want to find adjoint of 1 by 3 2 2 1 minus 2 1 2 1 minus 2 2. ஸோ இப்போ நீங்கள் அந்த ரிசல்ட் கம்பேர் பண்ணிங்க அப்படின்னா எனக்கு லாம்டா இருக்கிற இடத்துல 1 by 3 இருக்குது. ஸோ இன் பிளேஸ் ஆஃப் லாம்டா ஐ ஹாவ் 1 by 3 அண்ட் இது ஆர்டர், இந்த ஆர்டர் ஆஃப் மேட்ரிக்ஸ் 3x3 மேட்ரிக்ஸ் இது. ஸோ அதனால் நம்மளுக்கு n வந்து இங்கே 3. இங்கே சப்போஸ் 2x2 மேட்ரிக்ஸ் இருந்ததுன்னா n வந்து 2. சப்போஸ் என்னோட ஆர்டர் வந்து 2x3 இருந்துச்சுன்னா அந்த ரிசல்ட் ஒர்க் ஆகாது. திஸ் ரிசல்ட் வில் ஒர்க் இஃப் அ மேட்ரிக்ஸ் இஸ் அ ஸ்கொயர் மேட்ரிக்ஸ். தட் இஸ் ஆர்டர் ஆஃப் அ மேட்ரிக்ஸ் ஒன்று 2x2 இல்லை 3x3 இல்லை 4x4 அந்த மாதிரி தான் இருக்கணுமே தவிர மாறி இருக்கக்கூடாது. ஸோ இயர் ஐ ஹவ் லாம்டா இஸ் 1 by 3 and n is 3. So if I apply this result, I have 1 by 3 3 minus 1. So since n is 3, so 3 minus 1 into adjoint of A, 2 2 1 minus 2 1 2 1 minus 2 2. So I have minus 1 by 3 into square into adjoint of 2 2 1 minus 2 1 2 1 minus 2 2. So which is 1 by 9 into adjoint of 2 2 1 minus 2 1 2 1 minus 2 2. So it is easy to find adjoint of this matrix. இது நீங்கள் இன்னொரு மெத்தட்லேயும் போடலாம், பட் அது ரொம்ப நேரம் ஆகும். நீங்கள் இன்னொரு மெத்தட் எப்படி போடலாம் அப்படின்னா இந்த 3 உள்ளே மல்டிப்ளை பண்ணிக்கலாம். ஸோ பண்ணி ஏ என்ன ஆகிடும் உனக்கு 2 by 3 2 by 3 1 by 3 minus 2 by 3 1 by 3 2 by 3 1 by 3 minus 2 by 3 2 by 3. அது நீங்கள் கேல்குலேஷன்ஸ் போட்டிங்க அப்படின்னா உங்களுக்கு டினாமினேட்டரில் டேர்ம்ஸ்லாம் இருக்கும். அதனால் உங்களுக்கு மிஸ்டேக் பண்ண நிறைய சான்ஸ் இருக்குது. நீங்கள் இந்த ரிசல்ட் யூஸ் பண்ணிங்க அப்படின்னா என்ன ஆயிடுச்சு அப்படின்னா என் டினாமினேட்டரில் எந்த டேர்மும் வரல, எனக்கு நம்பர்ஸும் சின்னதாக இருக்குது. ஸோ அதனால் ஆன்சர் எனக்கு ஈஸியாகவும் போடலாம், பட் ஸ்டெப்ஸும் எனக்கு கம்மியாகும். ஸோ we need to find the adjoint of this matrix and then you want to multiply with 1 by 9 to get the answer. So how can you find the adjoint of this matrix A? So which is now adjoint of that matrix. I am calling this matrix as something, let us say A dash. So adjoint of A dash is determinant of, you want to start with 1. So 1 2 minus 2 1 and minus 2 2 1 minus 2 2 1 2 2 minus 1 2 minus 2 1 transpose. I am sure that you are able to follow here. First I will start with 1. So 1 2 minus 2 2 minus 2 2 1 minus 2 2 1 2 2 and I want to start again. I want to finish with the same row, which is 1 2 minus 2 1. And நீங்கள் இன்னொரு விஷயம் முக்கியமானது என்ன அப்படின்னா ஃபர்ஸ்ட் நான் டிட்டர்மினன்ட் போடுறேன், அதுக்கப்புறம் டிட்டர்மினன்ட் போடல. ஸோ ஐ மீன் சேஞ்சிங் திஸ் டு எ க்ளோஸ்ட் ப்ராக்கெட், அதுவும் நீங்கள் மாற்றிக்கணும். So this will be 2. In between you have to put minus. 2 into minus 2 is minus 4. And 2 minus 2 into 2 is minus 4. So minus 2 into minus 2 is plus 4. Minus 1 into 1 is 1. So minus 2 minus 4. So 2 2s are 4. Minus 1 into 1 is 1. So here I have 1 into 2 is 2. Minus 2 into minus 2 is minus 4. So 2 into 2 is 4. Minus 1 into 1 is 1. Here I have minus 2. 2 into 2 is 4. 2 minus 4. Transpose. So 2 minus of minus 4 is plus 4. So which is 6. Here again 6. Here I have 4 minus 1 is 3. And minus 2 minus 4 is minus 6. 4 minus 1 is 3. 2 minus of minus 4 is 2 plus 4, which is 6 again. So this is 3 minus 6 and 6. So I want to put transpose. So after applying transpose, I have 6 minus 6, 3. 6, 3 minus 6 and 3, 6, 6. So I found the adjoint of this matrix. What I want to do is I want to multiply with 9. So adjoint of A is equal to 1 by 9 into adjoint of this matrix, which is 6 minus 6, 3, 6, 3 minus 6, 3, 6, 6. So this is the adjoint for this matrix. You can also take 3 common outside, but that is no problem, that is not required. So adjoint of A is 1 by 9 of 6 minus 6, 3, 6, 3 minus 6, 3, 6, 6. So this is how to find the adjoint of the following matrices. I use the important result, which is adjoint of lambda A is equal to lambda power n minus 1 into adjoint of A. So by using this result, we can be able to easily limit the calculations. I'm going to move on to the second problem. Find the inverse of the following matrices. Find the inverse if it exists. I already spoke about this inverse in the last video. So find the inverse if it exists. If it exists. So the first problem is, I'm taking that as A. So A is minus 2, 4, 1 minus 3. Now I need to find the inverse of the matrix. First, suppose we know that the necessary condition for the inverse to exist is that determinant of A should not be equal to 0. If determinant of A is not equal to 0, then inverse exists. So again, watch the previous videos. So first I need to find the determinant of the following matrices. So now I have determinant of A. So determinant of A is minus 2, 4, 1 minus 3. So I have to multiply these two numbers, which is minus 2 into minus 3 is plus 6 minus 4, which is 2, is not equal to 0. So therefore inverse exists. This is an important step. Inverse exists for this matrices. Inverse exists for this matrix. So how to find inverse? We know A inverse is 1 by determinant of A into adjoint of A. We already found the determinant of A, which is 2. Now I need to find the adjoint of A. So how need to adjoint of A? Again, you have to interchange these two, which is minus 3 and minus 2, and then you have to multiply with minus sign, minus 4, minus 1. So this is adjoint of A. So A inverse is 1 by determinant of A into adjoint of A. So 1 by determinant of A is 2, adjoint of A is minus 3, minus 4, minus 1, minus 2. So this is the inverse of the following matrix. The second problem. I am taking that as A. A is 5, 1, 1, 1, 5, 1, 1, 1, 5. Now we need to check whether inverse exists for this matrices. For this we have to find the determinant. If determinant of A is equal to 0, inverse does not exist. If determinant of A is not equal to 0, the inverse exists. So I need to find determinant of A. Determinant of 5, 1, 1, 1, 5, 1, 1, 1, 5. So So first you have to take this number 5 into, then omit the corresponding row and column, which is, then I have 5 1 1 5. So omit the corresponding row and column, you will have 5 1 1 5. And then very important thing is that second term you have to put minus sign, and then you omit the corresponding row and column, you have 1 1 1 5. And then 1 into, then omit the corresponding row and column, we have 1 5 1 1. So you have 5 into, again you should follow the same procedure, which is 25 minus 1. Minus 1 into 5 minus 1. So 5 minus 1 plus 1 into 1 minus 5. So which is 5 into 25 minus 1 is 24, minus 1 into 5 minus 1 is 4, plus 1 into minus 4. So 24 into 5. So 24 into 5, which is 5 for the 20, 10, 20. So 120 minus 4 minus 4. So I have 120 minus 8, which is 112 is not equal to 0. Therefore A inverse exists. So A inverse exists for this matrices. Now we know how to find the inverse. You know how to find the inverse. So A inverse is 1 by determinant of A into adjoint of A. We already found the determinant of A, which is 112. So we need to find the adjoint of A. So how to find the adjoint of A? Again you have to follow the same procedure. Since A matrix here is 5 1 1 1 5 1 1 1 5. So adjoint of A, first you have to take this number and then 5 1 1 5, and then next row 1 5 1 1, and the third row, top row, which is 1 1 5 1, and again you want to end with the same row, which is 5 1 1 5, and at the top you have to put transpose. So I have 25 minus 1, 25 minus 1, and here I have 1 minus 4, here I have 1 minus 5, here I have 1 minus 5 again, and the next row 1 minus 5, and here 25 minus 1, here I have 1 minus 5. So here I have 1 minus 5, 1 minus 5, 25 minus 1 transpose. So 24 minus 4 minus 4 minus 4, 24 minus 4 minus 4 minus 4, 24 transpose. So to apply transpose, you need to interchange rows and columns. So I am changing this column into row, which is 24 minus 4 minus 4, and again changing this column to row, minus 4 24 minus 4, and again change this column to row. So I have minus 4 minus 4 24. So this is the inverse of adjoint of A. So A inverse is 1 by determinant of A is 112, which we calculated. Adjoint of A is 24 minus 4 minus 4 minus 4 24 minus 4 minus 4 minus 4 24. So this is the A inverse for the following matrix. Now again the third problem, you can easily do this in your own. So the third problem is 2 3 1 3 4 1 3 7 2. First you need to find the determinant of A, and if it not equal to 0, then inverse exists, and after finding the determinant, find the adjoint of A, and then you apply the formula, you get the result. So I am leaving this as homework sum. I am going on to the third problem. So third problem is if f of alpha is equal to cos alpha 0 sin alpha 0 1 0 minus sin alpha 0 cos alpha, you need to show that f of alpha inverse is equal to f of minus alpha. So it's very easy problem. First you need to understand two basic identity in trigonometry. You know that cos of minus x is equal to plus cos x, and sine of minus x is equal to minus sine x. So this is a result which we come across in the earlier classes. So cos of minus x is plus cos x and sine of minus x is minus sine x. So we need to find f of alpha. F of alpha is given. We need to find the inverse of this matrix, and you need to substitute in place of alpha. We need to substitute minus alpha, and you have to show that these two are equal. First I am finding LHS. So for finding LHS, I need to find f of alpha into inverse. So f of alpha inverse is equal to 1 by f of alpha into adjoint of f of alpha. So in place of a, I have f of alpha. So in place of a, I substitute f of alpha, and in place of a, I substitute f of alpha. 1 by determinant of f of alpha. So determinant of f of alpha is equal to determinant of cos alpha 0 sin alpha 0 1 0 minus sin alpha 0 cos alpha. So you have cos alpha 0 sin alpha 0 1 0 minus sin alpha 0. So I want to again find a determinant which is cos alpha, and then you omit the corresponding row and column. You end up with 0 1 0 0 cos alpha, and then you sub second term, it is 0 here. So there is no point in writing these terms, because since 0 multiplied by anything is 0. So here I have 0 0 minus sin alpha cos alpha plus sin alpha into, omit the corresponding row and column, you will have 0 1 minus sin alpha 0, and you have cos alpha. 1 into cos alpha is cos alpha minus 0. Minus 0 into anything is 0, plus sin alpha 0 minus sin alpha. In between you have minus, and 1 into minus sin alpha is minus sin alpha. So I have cos square alpha plus sin square alpha. So here I have cos square alpha plus sin square alpha, which is 1. So again the basic identity in trigonometry. Then I want to calculate adjoint of f of a. Adjoint of f of a. So adjoint of f of alpha, adjoint of f of alpha is equal to determinant of, first you have to start with the first term, the pivot element, which is 1 0 0 1, and the next row 0 cos alpha minus sin alpha and 0, and 0 sin alpha cos alpha 0, and you have to in the same row, which is 1 0 0 1 into transpose. So I have 1 into cos alpha is cos alpha minus 0. Here I have 0 minus 0. Here I have 0 minus sin alpha. So minus sin alpha, again 0 minus 0 is 0 again. So here I have, look at this carefully, cos square alpha, in between you have minus, here I have minus sin square alpha. So here I have plus sin square alpha. Cos square alpha minus of minus sin square alpha, which is cos square alpha plus sin square alpha, which is again 1. So I have sin alpha into 0 is 0. 0 into cos alpha is 0. 0 minus sin alpha, 0 minus 0, and cos alpha minus 0 transpose. So I have cos alpha 0 sin alpha 0 1 0 minus sin alpha 0 cos alpha transpose. So after applying transpose, I have the adjoint as cos alpha 0 minus sin alpha 0 1 0 sin alpha 0 cos alpha. So this is the adjoint of the following matrices. Now since the determinant of A is 1, determinant of f of alpha is 1, so f of alpha inverse will be 1 by 1 into adjoint of f of alpha. So which is 1 by 1, again 1 into adjoint of f of alpha is f of adjoint of f of alpha. So I have f of alpha inverse is equal to 1 by 1 into adjoint of a. Adjoint of a is cos alpha 0 minus sin alpha 0 1 0 sin alpha 0 cos alpha, sin alpha 0 cos alpha. So this is the LHS part. Then I want to find the RHS. RHS is f of minus alpha. So I have f of alpha is given in the question, which is cos alpha 0 sin alpha and 0 1 0 minus sin alpha 0 cos alpha. Now in place of alpha I have to put minus alpha. So f of minus alpha is equal to cos of minus alpha 0 sin of minus alpha 0 1 0 minus sin of minus alpha 0 cos of minus alpha. And again I am using this basic result. Cos of minus x is plus cos x, sin of minus x is minus sin x. So I have cos of minus alpha is cos alpha 0, sin of minus alpha is minus sin alpha 0 1 0. Here I have minus sin of minus alpha is minus sin alpha. Already have minus here, so this becomes plus sin alpha 0 cos alpha. So this is 2, this is 1. So from 1 and 2 you can see that these two are equal. So therefore from 1 and 2 I have f of alpha, the whole inverse is same as f of minus alpha. Therefore hence these both are equal. So in this video we solved the first 3 problems in exercise sums. In the next video I will solve the upcoming problems, and after finishing the exercise 1.1 I will solve the important theorems in the examples. So hope you enjoyed this video, and உங்களுக்கு எதாவது டவுட் இருந்தது, எதனா queries இருந்ததுன்னா நீங்கள் கமெண்ட்டில் தெரிவிக்கலாம். நான் கண்டிப்பாக அதுக்கு ஆன்சர் பண்ணுறேன். Goodbye, we'll see you in the next video. Have a great day. Bye bye.